Okay, good afternoon. My name is Chris Elam, East Central Service Advisor for GA Larson. I handle technical service for Rheem products, Mitsubishi, Climate Master, and any question that you may have. So in the chat feature, I put my name, email, and phone number. Best to reach me by phone, text, or email pretty much any time. So today's short class is going to be on inverter charging. This is going to be based more in terms of Rheem and not necessarily other brands in general. It's going to specifically tell you how to charge accurately Rheem inverters. So we'll go ahead and get started here. Okay, so charging an inverter system, it does require a little more skill than your entry-level service technician, basic superheat and subcooling, but it is otherwise pretty straightforward. You can tell by the controls, the size, and the components on these units. They're not your 8, 10, 12, 13, 14 SEER units. They do not use pistons or capillary tubes, so you cannot treat them as such. It is very critical to achieve the proper charge with these inverter units. It's super critical with downflow units and horizontal right units. First and foremost, the technician needs to understand that there must be a specific load on the indoor unit in order for pressures to line up with the chart. The pressures you see in the chart are gross pressures. Rarely will they line up identically to that, but you'll be somewhere in the ballpark depending on your outdoor temperature, and the load on your indoor unit. So we'll kind of get into some charging charts here in just a few minutes. So we ensure we have a load similar to that is being used in the charging charts. It is safe to say we don't have control over the outdoor temperature. So the charts accommodate various outdoor temperatures in both heating and cooling. We do have the ability to control the indoor temperatures. That's what we do for a living. So if it's super cold inside, if it's 60 degrees in the house, it's going to be difficult for you to charge it in air conditioning. So as far as Rheem inverters go, you have the 2 heat pump models. You have the RP17, which is your 3-stage 17 SEER inverter, and you have your RP20, which is your completely variable capacity 20 SEER, and then you also have your RA20, which is your variable capacity inverter AC. Some other factors: airflow, or the quantity of air that carries the heat, is crucial to achieve a proper charge. Go a little further with that. Not only is the amount of airflow crucial and critical, also your static pressure is crucial, or is even more crucial and critical in some cases. If your static pressure is above 1.0, your charge may look good and it may operate okay. It will probably operate fine in cooling, but when you go into heating, that's when everything changes. That's when you'll start getting, in some cases, overcharge, high pressure events. You'll also get a consistent batch of inverter errors, different error codes associated with that. So airflow is super crucial, and so is your static pressure. Also, when you're charging, ideally, you'll use the EcoNet control. That's what's designed to operate with. So in some applications, you may have to turn off airflow adjustments, dehumidification, to prevent any kind of airflow changes that you don't want to take place during charging. Then you can turn all that back on once the charging has been completed. None of those dehumidification, airflow adjustments were taken into consideration during the charging charts. So you're strictly in charge mode based upon these charts. So some following criteria that must be achieved in order to charge the units. For charging and cooling, the outdoor temperature must be between 55 and 99 degrees. Indoor temperature must be, they say, 80 degrees, plus or minus 2 degrees. That's a pretty heavy load. So if you're much lower than that, everything on your chart will be lower. If you're at 85, 89 degrees indoors, obviously your chart wouldn't correlate exactly. All your pressures would be much higher. For heating, if you're charging and heating, the outdoor temperature must be between 40 and 60 degrees Fahrenheit. Indoor temperature must be 70 degrees plus or minus 2 degrees. A big one is the system must be matched. We ran into this not too long ago. When you're using an inverter system, it must be matched up to an AHRI matched coil that also has a EEV within the coil or the air handler. If not, it will work fine in cooling for the most part. Or I take that back. It'll work okay in heating, but when it goes into cooling, it's going to run quite low. So you must have the proper match system, and that is a proper matched air handler, the RHMV air handler, or you have to have a proper, if you're doing a dual fuel gas furnace, you have to have a proper coil that has a EEV. The coils and filters must be clean. If they're not clean, it will skew your readings and affect your charge. And then all airflow adjustments must be turned off. And this is a big one. Ran into this the other day. Similar to a two-stage air conditioner or two-stage heat pump, these inverters, they must be running at the highest speed in order to check or adjust charge. If you're not running at the highest speed and it's not stabilized, by the time it does run at high speed and does stabilize, you may very well be way overcharged. Now, we had a situation like that the other day where they had put way too much refrigerant in it, and that compressor was making sounds that compressors were never supposed to make. Mainly because they were charging it in first stage cooling, and once it went into high stage, they had overshot it massively. So some examples of compressors: RP20, 24, two-stage, so you're going to be around the 3,000 RPM mark for cooling. RP2036B, 2,800 for cooling, 2,800 for heating. And you can verify your RPM speeds, inverter RPMs, from the EcoNet. So you'll get an idea that, yes, I indeed am running about where I need to be at. RP2048, you should be upwards around 3,750 on both cool and heat. And then RP2060, you should be somewhere in the range of 4,100 RPMs for both cooling and heat. So if you're approaching those RPMs, then you know you're in a stable high stage speed. And at that point, the unit just needs to run and stabilize. Now with the EcoNet, they have what they call a charge mode. So when you go into, on the EcoNet, you'll see a feature that'll say ODU checkout, which is outdoor unit checkout. You'll have low heat, high heat. You'll also have charge heat and charge cool. So depending on which one you're trying to do is either charge heat or charge cool, you will go into charge mode, and it will temporarily disable dehumidification and turn off any airflow adjustments. Also, it's going to immediately put it into high stage. so you know there's not a whole lot of waiting period. Within a couple minutes, you will be at the appropriate RPMs. Do verify airflow is where it needs to be for the equipment. This can also be done at the EcoNet. So from the EcoNet status screen, you can check your airflow CFM. You can also check on the same screen your static pressure. So if you have a 2-ton unit, you should be around 800 CFM, 3-ton, 1225, 4-ton, 1575, and 5-ton, 1700. So once you put it in charge mode, check your airflow, check your static pressure. Now, if by chance you're using people like the Nests and the Ecobees and Honeywell 8000s, whatever people prefer, you can wire these legacy, which does kind of reduce your troubleshooting, because you're now relying just on the boards and not on the EcoNet to tell you specifically what's wrong with it. But if the system is wired legacy, you have to ensure that both Y1 and Y2 are calling. Verify they're engaged, and then your circuit board will also tell you, based upon capital C or upper lowercase c, if it's indeed in second stage. You're unable to verify what RPM you're in because you don't have the EcoNet, but you can still run. Do allow the system to operate on factory charge for a while. Do not start making a whole bunch of adjustments. Now, a caveat to that is if you're in a downflow position and you have a short line set and you started up your factory charge, you may indeed be overcharged right out of the box. So if you notice your pressures are skyrocketing, then you'll want to recover some refrigerant to get to a stable level. So you're not going to start hitting high pressure. Once these are in charge mode, allow them to stabilize. They say, 15 minutes to be stable. I wouldn't make any adjustments until it's at least 30 or 40 minutes before you start, making any adjustments to the charge. What can happen is if you start adjusting too early and that unit continues to run and stabilize, your pressures will continue to climb, and then you may end up actually overshooting your subcooling and overcharging the unit. So my recommendation is, once you put it in charge mode or put it in high stage using the Y1, Y2, allow it to run for no less than 30, I would say 40 minutes minimum before you start adjusting your charge. At that point, it will be stable, and then you can make your proper adjustments. Do measure the outdoor temperature, the temperature of the air going into the outdoor coil, and then plot that on the charging chart. It is important to remember all the key bullets listed before. That's going to make all the difference in the world. Now, depending on your outdoor temperature and the load on your indoor unit, kind of plot those, which we'll get into in just a second. If the head pressure is much lower than the chart, you'll want to add refrigerant. If it's higher, you want to remove some refrigerant. So that kind of plays into a downflow or a horizontal right unit with a very short line set. You'll come right out of the gate overcharged, especially in heating. It'll be almost immediate. So if you notice your head pressure, discharge pressure is skyrocketing way early, start recovering some refrigerant to get that to a stable level. Wait for a period of at least 15 minutes between adjustments. So if you make an adjustment, there again, let it stabilize, because these are very, very, very critical. We're selling these systems as being, top-end systems, looking to save the customer a lot of money, not to create more problems for them. So don't shortcut them on the charge. If this thing is not charged properly, you can and will destroy compressors. they're not getting the savings and the efficiency that they're paying for, and they'll be callback nightmares if they're not done properly. So just an extra hour at the end of the installation, not even sometimes, but take your time and charge it correctly. Once you have the pressures similar to those on the chart, let it stabilize. At that point, you'll want to dial in specifically to the subcooling. Your pressures are just kind of a ballpark gross pressures to get you into the ballpark where you need to be, and then your subcooling will allow you to fine tune that. You must allow the system to stabilize and redistribute the refrigerant you added or removed. So every time you add some or remove some, you got to let it stabilize. None can be left in the accumulator, and the metering device must have settled as well. Now on the EcoNet 700 series thermostat, you can view most everything. You still have to put your gauges on to dial in, but the subcooling will be displayed on the 700 series thermostat, the outdoor unit status screen, only during charge mode. So if you have a really short line set, chances are you can be a little short on subcooling and be just fine. One thing I've learned with inverters, it's a lot better to be slightly undercharged than it is to be anywhere near overcharged. If it's an air conditioner, it's a little more forgiving. But if you're overcharged in a heat pump and it's an inverter unit, or any unit for that matter, but critically on the inverter units, if it's overcharged, it will cause you continual faults because it's smart enough to catch those, and it's going to protect itself. So if you have overcharges, it will give you high discharge pressure faults. It'll give you envelope protection faults. Overcurrent's a big one. Overcurrent's going to go along with static pressure and overcharge, and there's a few other ones you'll get as well. Whatever you do, do not overcharge the system. If a little's good, a lot's better, we'll buy you a new compressor with these. You can usually tell with the sound, because these are they're distinctly different sounding, but they're relatively quiet. If you overcharge one, they get violent. They do not like that, and you'll hear it. So as a rule of thumb, which we'll get into here in just a minute here, as far as charging the Rheems, you always want to undershoot what the required subcooling is, and that will give you some fudge factor to accommodate for real world issues. Now, if you are commissioning the system in temperatures below 40 degrees or above 99 degrees, you'll most certainly have to get it close and plan a return trip to finalize the charge when conditions are more suitable to the chart. There is a data in the charging chart for conditions outside of these ranges, but they're not going to be 100% correct, especially in heating below 40, because the accumulator may be storing some of the refrigerant. And above 100 degrees, it's way too easy to overcharge the system. Now, right here is a charging chart for a RP2036B. So it's very important here. This is on a 3-ton model. You'll see 2 sets of cooling, heating, cooling, heating. Now on the charging, on every chart, you'll see where it'll say UF/LH. So you have upflow and left horizontal airflow. Those are going to be in the same chart. If it's a downflow or a right flow horizontal, they're going to be in a different chart. If it's an air conditioning system, you'll usually see all coils or all orientations. It's just going to give you one chart to go by. But just for safe here, if we go to 47 degrees in heating on an upflow, our pressures will be somewhere around 295 and 110, and a subcooling of 13. Actually, you know what? Hold on, this is a different chart here. So let me go over, yeah, that's it. So we'll go over here to the downflow heating here. So 47 degrees here. If we follow this over, the 330 is not too far off from the 295. The suction pressure is 111, not terribly far off from your upflow, but you'll notice your subcooling is wildly different. In a downflow position, the required subcooling is 27, and in upflow it's 13. Now, ideally, you want to undershoot these by at least 3, if not 5 degrees, to kind of give you some leeway here, to not be anywhere near overcharged. So in this case here, if you're at a subcool of 13, I would shoot for a 10. And that's going to give you a nice safe spot there. If you're in a downflow, same chart, you're calling for 27 degrees. So at that point, I would probably shoot for like a 22. You're going to be 5 degrees under, and that's going to give you a nice safe spot in between without overcharging it. So about 8 to 10% less in that vicinity. The initial training was weigh everything in and let it go. But there's too many factors such as static pressure, ductwork, upflow, downflow. There's a lot of factors that go into this that can create monumental problems and monumental failures. So do follow your charts. Make sure that you know what your orientation is. Is it an upflow, left horizontal, downflow, right horizontal? And then dial it in accordingly. So if we'll go over here to the cooling, we'll take an 85-degree day. So 85-degree upflow, our head pressure should be somewhere around 297, suction 148. And if we go over here to cooling downflow, 85, really close again, 297 discharge, 139 on your suction, and it's calling for an 8 on your subcool. So in this case here, I would probably drop that by 3 and go to a 4 subcooling. And on your 8 over here, I would drop that by 3 and put that at a 5, maybe even a 4. And that gives you a nice safe cushion there to not be in the overcharged situation. Let me show you real quick. I'll show you on the EcoNet where you can find a lot of these. Okay, so this is the Rheem EcoNet simulator, which is on the my Rheem app. So this is what you're going to have on your main screen. So if you go into here, if you go into service, it'll give you any fault history that you have associated with that. And if it does give you specific faults, you want to pay attention to those. If you start seeing a trend of specific faults, you want to hone into that because that's going to tell you what's going on with it. If you go into the status here, this is super, super, super important. If you go into the status of the furnace, 4 down here on the left, it will tell you exactly what your static pressure is. And then that will tell you if this is above 1 point above, it's high. If it says it's unknown, it means it's so high it can't calculate it. So ideally, you want your static pressure below 1. So anything below 0.99 and down is acceptable. 0.99 is still high, mind you, but it's below the max. So here's your static pressure. If you follow up here, it will tell you what your CFM is and also your RPM. So you can gather this information while you're in test mode. Static pressure, CFM, RPM. Go back over here. If we go to the AC heat pump here, it kind of walks you through what you have. If you go to the additional screen, it will tell you exactly what your inverter current speed is. So if you kind of revert back to where you should be at, so if I think it was a 5-ton, it should be at 4,100 RPMs. So if you're in test mode and this is at 4,100 RPMs or close to it, then you know you've reached appropriate speed. Now it'll also tell you what your superheat is, suction line temperature, suction pressure. It will tell you pretty much at a glance everything you need to know. You still don't want to trust it 100%, so you'll want to have gauges on there as you're actually doing the charging. Now, if you had to adjust your airflow a little bit, say you were just on the borderline, you could go in here to this installer. You could go into the AC heat pump. Right here, you'll see what they call cool airflow adjust out of the box. It's going to be set at the optimal factory CFM. If you need to go down some, you can highlight the none and then go down to the lowest section, or if you need to increase it a little bit for whatever reason, you can highlight that and go up. Now, normally, if this is set up and actually communicating system, this outdoor unit section here would say EcoNet, and it would say locked, which allows you to basically, lock it. It can't change what it is. And then this variable speed RPM clamp right here, 7,000. That's the maximum RPMs that you can run. That can be toned down, highlighted, and adjusted down from 7,000 if customers complain about excessive noise. They'll sometimes get those in the hottest of days or the coldest of days, where it's at the highest RPMs or in overdrive is where you'll usually get your noise complaints. There we go. So that kind of, something clicked off here. Here we go. Kind of jumped around there. So that kind of goes over some of the charging. The biggest thing I can tell you is when you're selling these, make sure your static pressure is correct. It is 1.0 or below. Ideally, the lower the better. Will make it run that much more smoother. If it is high, it will put you in danger of inverter faults, even though the charge may look good. So it's kind of something to watch out for. So make sure you verify your orientation: upflow left, downflow right. Follow the proper charging charts. Allow it to stabilize for, I would say, 40 minutes at least, in my opinion. While you're there, you might as well make sure it's charged up correctly. Allow it to stabilize. Verify that your gross pressures are within tolerance, and then also undershoot your required subcooling by somewhere between 3 and 5 degrees, and that'll make a world of difference for you. That will keep the overcharging in the inverter vents to a bare minimum. Because with inverters, it's better to be a little bit low and let the inverter handle itself with the RPMs, then be over and cause irreparable compressor damage, as well as inverter faults and callbacks, because that's what really kills you. So that kind of sums up the charging for the Rheem inverters. I know a couple of you guys from the names here, you guys have attended the classes before, and I think a lot of the inverter issues with charging has been worked through. But anybody have any questions? Okay, well, if there's no questions, if you have any questions later, feel free to give me a call, send me an email, send me a text. I'm happy to help you. So I do appreciate you taking your time out this afternoon to listen to the class. So you all have a good day, and once again, thank you. Thanks.